Hello everyone. So we will work on some predicted questions now that can come in the upcoming test. And all these questions that we will be discussing are from the past papers. But when working them out, we will brush up the concepts as well. You can also download a PDF of these questions using the link in the description. So without wasting time, let's get started. Question 8a. So I have also added the code just above each of the questions. So if you want, you can just use the past paper as well for that. So let's get started. Question 8a. Now, this is a sequence related question that you can expect. So I have added added a few more sequences as well. Now, when an nth term is given like this, to find the first three terms, you just substitute 1, 2, 3 for the value of n, and you can find the answers. So in this case, it will be like 10 minus 1 squared. Then we would do 10 minus 2 squared, 10 minus 3 squared. You can find the answers. That will be the first three terms. So in this case, it's going to be 9, 6, and 1. So these are the first three terms of this of the sequence when the nth term is given. Now there's a sequence given here. Now we need to find the nth term. When finding the nth term here, so first you need to find the difference between the terms. So here it increases by a 3 each time. This forms the first part of the nth term, which is 3n. Now to find the next part of the nth term, you're going to see how much more we need to add or subtract from this difference here to reach the first term. In this case, I will have to add 4. So that connects with the next part of the nth term, next part of this first part of the nth term that we have written. This is going to be the nth term for this sequence. When we check this sequence that is given here, in this case, we can clearly see that now when we check the difference here, from 8 to 17, there is a difference of 9. Then 17 to 32, there's a difference of 15. Then we have 21, 27. Here, the difference is not the same like in this question that we did here. So that is when we have to find the second difference as well. So when we find the second difference here, in this case, the second difference is going to be 6 because each of these numbers is going to increase by a 6. This is when we realize that this is a quadratic sequence. So if it's a quadratic sequence, the nth term of a quadratic sequence will be of the form an squared plus bn plus c. Now we need to find what this a, b, and c is for us to find the nth term of a quadratic sequence. For us to do that, you have to remember the formulas that we have when it comes to a quadratic sequence. That's very important. So this first number that we have here will be equal to a plus b plus c. This will be equal to 3a plus b, and this will be equal to 2a. So these formulas are very important. We have to remember them. Now, for me to find what a, b, and n is, so the first term here is, the number that we have here is 6. So 2a is equal to 6. So as 2a is equal to 6, I can find what a is. So to find what a is, I need to divide both the sides by a 2. That will be equal to a 3. This forms the first part of the quadratic sequence's nth term. So that's going to be 3n squared. The a is replaced with this 3. The next one is, now that I know what a is, I need to find b. So 3a plus b is equal to this 9. So as 3a plus b is equal to 9, I'm going to substitute the value of a that I have already. So that's going to be 3 times 3. The value of a is a 3. Plus b is equal to 9. So 3 times 3 is a 9. Plus b is equal to this 9, which means the value of b is 0. That means this part is a 0, so I'm not going to write that. I now need to find what c is. I'm going to use this equation then. So that's a plus b plus c is equal to 8. I know that a is 3, b is 0. I need to find what c is. So 3 plus 0 is 3. I need to take the 3 to the other side. It gets deducted from this 8, leaving you with the value of c. So that is 8 minus 3 will be equal to a 5. This is going to be the value of c. I need to replace this c with this 5. So that's going to be a positive 5. So that's going to be 3n squared plus 5. This is the nth term of this quadratic sequence. The next sequence that I have written here is a fractional sequence. So when we have fractional sequences, we need to do in the form of two separate sequences. That is, we need to do the numerators separately and the denominators separately. When we check the numerator that we have, I'll write it here as 7, 10, 13, 16. We need to find the nth term for the numerator separately, the numerators, the series in the pattern in the numerator separately. And for the denominators also, we need to separately find the nth term. So this is what we have in the denominator. Now, the numerators that we have here is similar to this sequence, which we already found the nth term. So here, the nth term of the numerator will be 3n plus 4. When we consider the denominators here, we have 27, 81, 243, and 729. This is not a quadratic sequence, because this sequence, if we try to find the differences here, the first difference or the second difference, it will not be the same, because this is not a quadratic sequence. But each of these numbers here, each of the terms here are formed by multiplying the previous term with a 3. So this is like an exponential sequence, which means it's going to be something like, as I'm multiplying by 3 each time, it's going to be like 3 to the power n. But if I replace this n with 1, if I'm to find the first term, I should replace this n with 1. So that gives me 3 to the power 1, which is equal to a 3. But in the sequence, I have 27. So to get to that 27, I need to make sure to add a 2 to this n here, which means when I replace 1 for this n, it becomes 1 plus 2, which makes a total of 3. So 3 to the power 3 is equal to this first term, which is 27. So then I know the nth term for the numerator and the nth term for the denominator. Now you need to write that in the form of a fraction, just like the fractions are given here, which means here the nth term will be 3n plus 4 over 3 to the power n plus 2. This n plus 2, that is an index. So now you might definitely, like most probably you will get a question related to the sequences, and it's important to know how to do quadratic sequences, at the same time exponential sequences. Let's move on to the next question that we have. The next one is a direct proportion question. So you might get a question related to direct proportion or inverse proportion. So we can expect a question like that. In the question here, it states that y is directly proportional to the square of x plus 3. As it says that this is directly proportional, it will be y is equal to k times the value of whatever the x that they have mentioned here. So it states that it's going to be the square of x plus 3. So it's going to be x plus 3 square. But let's say that the question in the same question was given as inversely proportional. If it's given as inversely proportional, in that case, we would write it as y is equal to k. We do not write it as times by x plus 3 squared. We would write it as k over x plus 3 with the square. So in directly proportional means you would just multiply it with whatever the expression that you have is. And if it's inversely proportional, you would put whatever that it follows with the square of x plus 3, or sometimes it will be given as square root of x or something like that. So that should be written in the denominator. Now, after that step, everything else is going to be the same. The value of x and y is given to you. You replace the value of x and y with this 2 and 5. So y is 5, that is equal to k times the value of x is 2. So it's going to be 2 plus 3 with the square. So 5 is equal to k. 2 plus 3 is 5. So that's going to be 5 squared. So if I'm to find what k is, I need to divide this 5 with 5 squared. That is equal to k. So 5 over 5 squared is 25. I can simplify this k with this one of the 5 that I have in the denominator, or 5 and 25 I can simplify. That will give us 1 over 5 as the value for k. Now that I know that the value of k is 1/5, I can substitute this back into the equation that we have here to replace this value of the value of k with this 1/5. So that's going to be y is equal to 1/5 I'm going to replace this k with 1/5 times this x plus 3 with the square. Now the next part of the question is to find what y is when x is 1. Now that we know the value of k and the value of x is given, this value of x that is given to us should be substituted and we can find what y is. So which is 1/5 times the value of x is given as 1. So it's going to be 1 plus 3 with the square. So 1 plus 3 is 4. 4 squared is going to be 16. So it will be 1/5 times 16. So this is the same as 16 over 5. So when I divide this 16 by a 5, I can write that answer as a decimal as well. So when I divide this 16 by a 5, I end up getting 3.2. So 3.2 is the value of y. We will do the same thing even if the question was given as inversely proportional, but the only difference is that the value that we have here should be written in the denominator. The k should be in the numerator. Let's move on to the next question that we have. So here the question given to us, given here is a compound interest question. So we need to know the compound interest formula. So the compound interest formula is A is equal to P times 1 plus R over 100 to the power n. So here, this P is the amount that you are starting with. A is the final amount. Now, this formula is not only used for compound interest questions. Now, there are questions where there is an exponential growth. Now, for example, now if there is a question that says like a population of something keeps increasing, that's going to be something like an exponential growth. In that case, also we would be using this formula. So just like that, if there is an exponential decay, so exponential decay means, for example, now if I say something like there is a radioactive chemical or radioactive element, it's something relating the half-life of it. It keeps reducing over a period of time. If something like this is given, in that case, what will happen is we can use the same formula, but as it keeps decreasing over a period of time, in that case, instead of addition, you would be replacing it with subtraction, and then we can use the same formula to do the question. So when something keeps decreasing, like an exponential decay, in that case, we would use the same formula with a minus. And when there's something, when something keeps increasing over a period of time, in that case, we would use the same compound interest formula. In this case, as it's compound interest, we will use this first formula that we have, which is A is equal to P times 1 plus R over 100 to the power n. In the question, it states that Anya invests $6,000 in an account that pays compound interest at a rate of R% per year. And at the end of 8 years, the interest earned is $621.70. We need to find the value of R. In this case, this is the amount she starts with. So I need to replace this P with that starting amount, which is 6,000. Times 1 plus R is what I need to find. So I'm going to write it as R over 100. And n is going to be the period of time, which is 8 years. So I'm going to replace this n with 8. This is equal to A. This A is the final amount. Now here, the final amount is not the interest. The final amount is the amount we started with plus the interest together, which means we have 6,000 here and we have 621.70. Together is what we need to substitute here. So that's going to be $6,621.70. So this is what I need to substitute here. Then what I got to do is I need to rearrange this equation to find what R is. So to do that, I need to bring the 6,000 to this side. So the 6,000 is already multiplying when it's in this side. So when I take it to the other side, it gets divided. So I need to divide it by 6,000. This is equal to 1 plus R over 100 to the power 8. Now I'm going to put this in the calculator. So I have 6,621.70 has to be divided by 6,000. So when we do that, this is what we get. Now this is equal to 1 plus R to the power R over 100 to the power 8. Now I need to get rid of this power 8. So I need to do the opposite of it, that is to do the 8th root of it. I have to do the same thing to this side as well. This way I can get rid of the roots. Now this will leave me with 1 plus r over 100. So this 1 plus r over 100 will be equal to, now to this answer that we get, we need to do the 8th root. So I'm going to do the 8th root of the answer that we have. So I'm going to put the answer that we got previously, and this is what we get. We get 1.0124. So I will write it as 1.0124. And keep in mind, do not round it to 2 decimal places or 1 decimal place here. If you do that, the rate will become incorrect. So I'm going to write to about 4 or 5 decimal places. That is how it should be written. Now I need to bring the 1 to the other side because I need to isolate this r. I need to make r the subject. So to bring the 1 to the other side, I need to deduct 1. So that becomes 1.0124. From that, I need to deduct 1. This will be equal to r over 100. And then I need to take this 100 to the other side. This 100 is dividing. If I'm to take it to the other side, it gets times. So with whatever the amount that I have, that I get here after the deduction, that amount has to be times with 100 for me to find what r is. So then let's see what we get. So from this number, I need to deduct a 1. This is what I get. Then I need to times it by 100. So this gives me the answer, the rate as a percentage, which is 1.24%. So R is equal to 1.24%. So this is how we do it. Now, there are compound interest questions where we will have to find the value of n. The process will be the same, but there is a difference. You would take the 6,000 to the number that we have here, the value of p to the other side, so the a gets divided by p. After that step, what we got to do is we need to get rid of this n. But that is what we are supposed to find in the question. So you can solve whatever that is inside the brackets, that is by adding 1 plus, the rate will be given to you, r over 100 we can solve and make it into one number. That number to the power n will be equal to a value in the left side. Now, in that case, for you to find what n is, you will have to use the trial and error method. So you will replace the value of n with several values until it matches with the value that we have in the left side of the equation, or is very closer to that amount that we have. That way we can find what n is. So that is how it should be done. Let's move on to the next question that we have then. Okay, this question that we have here is a bearing question. When it comes to bearing, there are 3 things to keep in mind. One is it should always be measured from the north, and it should be measured in the clockwise direction. Clockwise direction is going to be this way. And the third one is we need to make sure to write it using 3 digits when we write our answer. So for example, if you get the answer as 62 degrees, in that case, we would write it as 062. So that's very important to keep in mind. Let's work on this question that is given here. So the diagram shows the position of 3 towns. So the 3 towns are given, and U is due west of V. So this is in the west of V, and the angle UVW, so that is, this angle is given to us as 125 degrees. We need to calculate the bearing of U from W. This point is very important as well. It clearly states that we need to find the bearing of U from W. So to identify which angle to measure, first the 2 locations mentioned in the question should be marked. So the 2 locations mentioned are U and W. So this is U, this is W. Once when you identify the 2 locations, connect the 2 locations with a straight line. So it's going to be like this. Once when we do that, as it states that to find from W, whatever the location that we have after this from, that is where the angle has to be measured. So in this case, I need to measure from W, means at W, I need to measure, not at U. At W, I need to measure. At W, draw the north. It's already given to us. From that, start measuring the angle until you meet the line connecting the two locations mentioned here, which means in this case, I need to measure what this angle is. I need to calculate how much that angle is. Now, for me to do this question that is given here, first what I got to do is, now according to this diagram that is given to us, I know this side is 62.4, this is 125 degrees, and this side is given to us as 27.3 kilometers. So in this question, I will have to make use of the sine rule for this question. The reason is because here I cannot work out this angle or I cannot work out this angle. So for me to find this angle, the way how I'm going to do is, I'm going to first calculate how much this angle is. Then after I calculate what this angle is, using the interior angles of a triangle, I can find how much this angle is. At this point, I would draw the north, and then I will be able to calculate how much this angle is, because this is north and this side will be east for this U. I will be able to calculate this angle. If I can calculate this angle, I will be able to calculate how much this angle is, because you can see we have this C shape here. So these are co-interior angles. So using the co-interior angles, I can find how much this angle is. Then finally, I can find how much this angle is. That's because around a point, the angle sum will be 360 degrees. So if I'm to find how much this angle is, then from 360 degrees, I can deduct this angle that I have marked here. So this is what I'm going to do. So then let's work on this question. So first what I'm going to do is, I'm going to calculate this angle. I cannot find this angle now because the side opposite to the side given is this side. This side is not known. So this side and the angle both are not known. So I won't be able to work that out. That's the reason why we need to calculate this angle. So for this side, this is the angle that is opposite to it. For this angle, this is the side that we have opposite to it. So I can use the sine rule. So in this case, the sine rule is going to be, I'm going to write the sides at the top. So it's going to be 62.4 over sine of the angle. So that is the sine of the angle that is right opposite to that side, which is this 125 degrees. This is equal to, I'm going to write the side now, which is 27.3 over, I need to find how much this angle is. So I do not know. So I'm going to label it as sine W. I'm going to find what that angle is. So here sides are written at the top, and their respective sine angles that are opposite to those sides are written at the bottom. I need to isolate and find what W is. This W is an angle. I need to find what that angle is. So when we have two fractions like this, to solve this, always cross multiply. Even if it's algebra, we have to cross multiply to solve it. So I'm going to cross multiply it. And when I cross multiply, I get sine W times 62.4 or 62.4 times sine W. This is equal to these two gets multiplied, which is 27.3 times sine 125. Now I'm going to bring this 62.5 to the other side. So I'm going to divide it by 62.5. Only then I can get rid of the 62.5 in the left side of the equation. So I can get rid of this. So that will leave me with sine W, which is equal to 27.3 times sine 125 over 62.4. And keep in mind that do not use the calculator and first find what 27.3 times sine 125 is. Then do not round it to 2 decimal places and then do the division, and then again do not repeat that over and over again, because sine, cos, tan, they are very sensitive for even very small changes. Therefore, completely rearrange and isolate W, then enter that into the calculator to find the value of the angle. So then I'm not going to enter it into the calculator now itself. I still need to make W the subject. Now sine W is equal to 27.3 times sine 125 over 62.4. So if I'm to find what W is an angle. Even in trigonometry, when calculating an angle, we have to use inverse. inverse is used only when calculating the angle. So that is what I'm going to use here. So to find what W is, I need to use the inverse of sine for whatever the amount that I have in this side. So in the other side, I have 27.3 times sine 125 over 62.4. So now I'm going to put this in the calculator and see what I get as the angle for W. That will be this angle. So then let's put this in the calculator. So then we have it as inverse of sine. I'm going to put the fraction 27.3 times sine of the angle, which is 125. And in the denominator, I have 62.4. So then I'm going to close the brackets and I'm going to check the answer. So I get 21.0067, which means correct to 2 decimal places will be 21.00, which means the angle is 21 degrees. This explains that this angle that I have here is going to be 21 degrees. Now, previously, we couldn't find what this angle is directly. Now that we know how much this angle is and how much this angle is, this is a triangle where all three angles, or two angles are known, where we can find the third angle, that is this angle, because the angle sum in a triangle is 180 degrees. So then from 180, I can deduct this 125 and 21 to calculate how much this angle is. So that is what I'm going to do now. From 180, I'm going to deduct 125 and 21. I'm going to deduct both the angles. So that is equal to 34, which means this angle is 34 degrees. Now, like I mentioned previously, I'm going to find how much this angle is. I'm going to draw the north and calculate how much this angle is. Now, this is the north for you, and this side will be the east for you. That means in between north and east, the angle is 90 degrees, which means if I'm to find how much this angle is, from 90, I would deduct 34 degrees. So I'm going to use the calculator again. So from 90, I'm going to deduct 34, that's equal to 56. Now I know that this angle is 56 degrees. Now using this angle, I can now calculate how much this angle is. The reason is because I can form the C shape here. So angles in the form of a C in parallel lines, they are called as co-interior angles. And in parallel lines, co-interior angles make a sum of 180 degrees, which means this angle and this angle together is equal to 180 degrees. Therefore, for me to find how much this angle is, from 180, I would deduct 56 degrees. That will give me how much this angle is. So from 180, let's deduct 56. So when we do that, we get 124 degrees. So this angle is 124 degrees. Now I can find the angle that I have marked in pink, because that is the angle that we need to calculate. That's the bearing of U from W. So for me to find how much this angle is, from 360 degrees, I would deduct this angle that we just found, which is 124. That will give us the bearing of U from W. So from 360, when I deduct 124, we get 236 degrees. This is the bearing of U from W. With that, we will be done with this question. Let's move on to the next question that we have. This is one of the most important question that you need to understand properly. That's because there are very high chances that you could get a question like this, especially part B, a question like this, where you will be asked to find the values that X could be. So that's very important. So let's work on this question. So then in this question given to us, we are asked to sketch the graph y is equal to cos x, and the range is given from 0 to 360 degrees. Now, I'm going to first explain how a sine graph would look like. Y is equal to sine x, and let's say this is x. We're going to split this into 4 sections of 90-degree angles. So it will be 90, then the next 90 is going to be 180, 270, 360. Now, whether it's sine or whether it's the cosine graph, it will go up to a maximum of 1 and minimum of 1. So this is for a sine graph and a cos graph. And a sine graph would look like this. It will go up to this point, and then it would reach this point. Then it would go up to -1. So it's going to be somewhere over here. So it's going to go like this. And then it's going to go like this. So this is how a sine graph would look like. A cos graph will be, now I'm going to draw the cos graph here. But before I do it, like I have split it into 4 90-degree intervals, I'm going to do the same thing here as well. So in between 0 and 180, I have 90. So that's going to be here. In between 180 and 360, I have 270. So that is here. Now I need to start drawing. So the maximum and the minimum in a cos graph will also be 1 and -1, just like in a sine graph. When you draw the curve, it should start from this. It's going to reach this point. So it will be like this. Then it's going to go up to this -1 when it's at 180. So it's going to be like this. Then from here, it's going to reach 270. So it's going to be like this. And then at 360, it's going to be 1. So it's going to be here. So this is how the graph will be. This is how the cos graph will be. Then the next one is, I'm also going to explain how a tan graph would look like. When we consider a tan graph, so this side I'm labeling it as x. So here y is equal to the tan value of the angles will be marked. Now again, I'm going to split this into 4 intervals. So that's going to be 90, 180, 270, and 360. In a sine and a cos graph, the maximum it will go is +1 and -1. But in a tan graph, it does not have a maximum value because it will go until infinity. And when we draw the tan graph, we got to start here, and it's going to go like this. Then from here, it's going to reach this point. And then at this point, it's going to go up again like this in the shape of a curve, like an exponential graph. But then this line that we have here, it will never touch with this 270-degree line, but it will 270-degree line or 90 line, because they are going to go until infinity. So then in that case, it will go very close to that line, but it will never touch that line. And here I'm going to draw it like this. This is how, and how a tan graph would look like. These 3 graphs, especially the sine graph and cos graph, are very important because there are several questions that have come in the paper where you are asked to draw a sine or a cosine graph. So you have to know all 3 graphs. Let's move on to the next part of the question. Now here, solve the equation 5 cos x plus 3 is equal to 0, and we need to find the value of x within this range. There are 2 values that we have within that range. That is what we are going to do. So first, we are going to rearrange this and find what x is. So to do that, I need to first take the +3 to the other side. So it will be 5 cos x is equal to 0 minus 3. The +3, when it goes to the other side, becomes -3. Then the 5 is multiplying. If I'm to take it to the other side, it gets divided. So I get cos x is equal to -3/5. If I'm to find what x is an angle, like I explained previously, when in the bearings question, I did tell that when calculating the value of the angle, you should always use inverse. So in this case, as it's given as cos, we need to use cos inverse of this fraction that is given to us, which is -3/5. I'm going to put this in the calculator and see what I get as the value. So that's going to be inverse cos. And I'm going to write negative, and then I have 3/5, and then I'm going to close the brackets, and I end up getting 126.87 degrees. That is correct to 2 decimal places. So then 126.87 degrees is the value of x. but this is just one value for x. I now need to calculate the other value for x. So that is the trickiest part. So here, out of, this is a 3-mark question. So for this one, we will get 1 mark. The other 2 marks will be for the next angle. So in that case, to do that, now in this case, to find what the other angle is, it's going to be like this. Now, when we consider a diagram like this, we call this as a unit circle. So we are going to have, we need to have an idea about how to use unit circles, because now we know that there is an easier way to do for this question, that is using 360 degrees. From 360, I can directly deduct this 126.87 and find the other value for x. But that will not work for all. It may have negative values. Sometimes it will have cos. The cos value here can be a positive value, a negative value, like that. When that happens, in that case, we cannot use that method. So we will have to have an idea of how to make use of unit circles to find the other angle. Now, the first step that you would do is in a unit circle. So first we will learn what a unit circle will be. So when we consider a unit circle, this is how a unit circle is. Now, this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. And when measuring angles in trigonometry using these unit circles, it's measured in the anti-clockwise direction, which means I need to start at 0. So this is where 0 is. In the anti-clockwise direction means this is the direction I need to start measuring. So this is 0 means when I measure up to this, it will be 90 degrees. This angle from here to here, it will be 180. Then another 90 from here to here, it's going to be 270. And then back again to this point is going to be 360. So I will just mark 180 here and the other 360 here. If we want, we can mark 90 and 270 as well, so that it's easier for us to calculate the angle. Now, the next thing that we need to do is, this step is what we need to use. Now, we rearrange the equation and we made cos x, or the cos angle, the subject. Now, when we look at this step, the value that we have for cos is a negative number or a negative fraction. Cos x, the value of cos x is what we're trying to find, not x, cos x. Here we have a negative value. So from this, we can say that the cos angle that we have is a negative value. This is very important. Likewise, now whether it's sine or tan, first rearrange the equation and form it in this way, so that cos x is equal to whatever the amount is, or tan x or even sine x. You check if the value is a negative value or a positive value, no matter what number that is there, or it can be a fraction either. We need to just check if it's negative or positive. Now we know that the value of cos is negative, which means in the 4 quadrants, we need to check in which quadrants will cos be negative. So for us to remember, in an easier way, I have written it as all silver teacups, which means in the first quadrant, all means all three trigonometric ratios, which is sine, cos, and tan, will be positive in that quadrant. Silver means in the second quadrant, silver, the S in that silver stands for sine. So sine will be positive in the second quadrant. That's the meaning. T means tan is positive in the third quadrant. So this is the third quadrant, tan is positive here. And cups means in the fourth quadrant, cos is positive. So this is where cos is positive, which means in the second quadrant, cos and tan will be negative. In the third quadrant, sine and cos will be negative. And in the fourth quadrant, sine and tan will be negative. Which means now we know that this is where cos is negative, and this is the next part of next quadrant where cos is negative. As it states that cos is a negative value, we need to select the quadrants that are negative for cos, which is the second and the third quadrant. Using those 2 angles only, we need to calculate the value of the other angle. First, after we identify the quadrant, we're going to put this value that we found for x here. We're going to draw it. So this is 126.87 degrees, which is an obtuse angle. So I need to start from this 0, and 126.87 means it's going to be like this. This is going to be that 126.87 degrees. Now, as it says that cos is negative, you find which quadrant is the other quadrant that is negative for cos. That is the third quadrant. We reflect this shape onto that quadrant. Now, even if it's sine, we draw the angle and reflect. Now, let's say the sine is a positive value we get. In that case, you would draw the sine angle. So that's going to be an acute angle. So you would draw it. And then you would reflect it into the other quadrant where sine is positive, which means as sine is positive in the second quadrant, we would reflect that angle onto the second quadrant. But here, as cos is negative, we should reflect it into the third quadrant. So I'm going to reflect this into the third quadrant. It's like I need to consider this x-axis as the reflection line, the line of reflection. So when I reflect it, the angle that I would get will be like this. So it's going to be like this, which means this angle also will be the same 126.87. But we know that when measuring the angle in unit circles, it should always be measured in the anti-clockwise direction, which means starting from 0, I need to measure the angle in the anti-clockwise direction until I meet this reflected line, which means this is going to be the other angle. So we need to find how much this angle is. That will be the answer. To find that, we know that the angle sum around this point is 360 degrees. I can deduct this 126.87 from 360 degrees to find the value of this angle. That is how I know that from 360, I need to deduct 126.87. So when I do that, I end up getting 233.13 degrees. So the two angles are 126.87 degrees and 233.13 degrees. So I will get rid of this diagram. We do not need that. So this is how we would be doing it. I hope this is very clear. Whether it's sine, cos, or tan, we got to follow the same process. Make sine x, cos x, or tan x the subject. Check if it's negative or positive. Find one angle using the calculator. Put that in the quadrant in this unit circle. And if it's negative, or identify the region that they have mentioned, whether it's negative or positive for sine, cos, or tan. Accordingly reflect it and start measuring the angle. That will be the other angle. Now let's move on to the next question that we have. The next question is about about a quadratic graph. So the previous question is a very important question, especially the angle that we found using the unit circles. That is very, very important. Now let's move on to this one. So in this case, the graph isn't very important. I mean, these two values we can easily find by substituting the value of x given here to this equation. That way we can find the value of y. But the most important part in this question is this one, this question that we have here. If you do not get this question in paper 2, most probably there's very high chances that we can get in paper 4. So I'm going to explain it now. So now to find the value of y here, we would just replace this x with minus 0.5 with the square. So 3 times minus 0.5 square minus 2 times the value of x, which is minus 0.5, and then we have minus 1. We're going to put this in the calculator and find the value of y. That is 0.75. We got to do the same thing here, but this time to find 0.5's value, we need to replace this as 0.5. That way we get the value as minus 1.25. So I'll just mark it like this. I'm not going to put this in the calculator. So this is what we get. Now, once when we do that, we need to mark the coordinate points, and then we're going to graph it. So then let's mark the coordinate points. I have now marked the coordinate points, and now I'm going to connect this to form a curve. So I have drawn the curve now. So it should be a smooth curve that you are drawing, and make sure you do not have any feathering lines. Now, the next part is, by drawing a suitable straight line, solve the equation. So this is very important, like I already mentioned. Now, when doing a question like this, first write the equation of the graph that is given. So which is y is equal to 3x squared. So I'm going to write it as y is equal to 3x squared minus 2x minus 1. First write that equation. So this is the equation of the graph. Once when the equation of the graph is written, write the equation given here just below that, but make sure that the equation is equal to a 0. So here it's already equal to a 0, and I'm going to write it below this. So I'm going to write the 0 here, and the terms that are like terms, I'm going to write it just below that. So I have 3x squared, and then I have minus 4x, and then minus 2. Write the equation this way after making it equal to a 0. Always it has to be made equal to a 0, and then written like this. And simply, from the equation of the graph, subtract the equation that we have written here. So when we do that, we get y minus 0, that is y. 3x squared minus 3x squared becomes 0. So these two cancels out. We have minus 2x minus 4x. So minus 2x minus 4x we got to do. So this is the same as minus 2x plus 4x, that is equal to plus 2x. So this is equal to 2x. I'm going to write that 2x. So I have the equal here. Okay, so I have the equal sign and 2x here. Next, it's going to be minus 1 minus 2. So I'm going to do minus 1 minus 2. This is the same as minus 1 plus 2. That is equal to a plus 1. So I'm going to put that plus 1 here. So the equation is y is equal to 2x plus 1. This is the straight line that we are supposed to draw, because in the question it clearly states that we need to draw a suitable straight line. Even if it's not mentioned, this is that line we are expected to draw. So that is found by deducting the equation given here from the equation of the graph. So we have y is equal to 2x plus 1. So first I'm going to mark the y-intercept. So in this y is equal to 2x plus 1, this 1 plus 1 is the y-intercept. So this is where plus 1 is. So I'm going to mark it. Then the next one is the gradient. So that is, the gradient is 2. So this number in front of the x is the gradient, which is 2. So here, when we consider any whole number, the denominator of the whole number will always be 1 if there is no denominator given. Which means to find the gradient is equal to rise over run. So I can do rise over run for this 2 over 1, which means from the y-intercept, I need to go up by 2 units and across by 1 unit, that is to the right by 1 unit. From here, I'm going to go up by 2 units. So it's going to be here, and across by 1 unit, to the right by 1 unit. But in this case, 10 small boxes represent 1 unit in the y-axis, but in the other side, 20 small boxes represent 1 unit. So we need to make sure to represent 1 unit, which means it's going to be 20 boxes across. So the coordinate point will be here. This is when it goes 1 unit across. So I have marked the coordinate point. I'm going to do the same process at the bottom as well. So 2 down and 1 across. So it's going to be here. So I have marked the points. Now I'm going to connect these points with a straight line to draw that straight line. So I have now connected it with a straight line. This is how the graph is. Now to solve an equation like this means to find the value of x. But we are expected to find the value of x using the graph. Now that we have drawn it, at the place where the straight line graph and the quadratic graph intersects is going to be the value of x that we are expected to find. That is, this is where it intersects. So at this point, we need to find the value of x. So we have 0 here, minus 0.5. This point that is given to us is, this point that we have here is minus 0.4. That's going to be our answer. So then the value of x is minus 0.4. In this case, the straight line meets the curve at just one point. That's why we have one value as the answer. Sometimes the line that we end up getting will be a straight line if it's mentioned as y. If the straight line we get is y is equal to 0, in that case, we will have two values. Or sometimes now in this, even if it's a slanted line, we can end up getting two values as well. But the process will be the same process. Now that we are done with this question, let's move on to the next one. Now, in this question, this is a question that is related to straight line graphs. Two coordinate points are given to us, which is C and D. The first question is to find the midpoint. Second one is to calculate the gradient. And then the next one is to find the equation of the perpendicular bisector of CD. First, when it comes to straight line graphs, there are three equations that we have to remember. The first one is to calculate the gradient. To find the gradient, the equation is we write the difference of the y values at the top over the difference of the x values that should be written at the bottom. So this is one way. This is the equation to calculate the gradient. Or we can even use rise over run. But when it comes to coordinate points, this is the equation that we should use. Then the next equation that we have is to calculate the distance. Now, the distance formula is going to be like the Pythagoras theorem. So that is, you find the difference in the x values, square it. You find the difference in the y values, square it. And then this entire thing has to be square rooted. This will be the distance formula. So this is like for rise and run, we are trying to, you're squaring the rise and run, and then adding them together and square rooting it. It's like we're trying to calculate the hypotenuse. Then the next formula that we have after the distance formula is the midpoint formula. The midpoint formula, in the sense, this is to find the coordinates of the midpoint. This is very important as well. So that is, when we write the coordinates, the x value is written first and then the y value, which means the two values of x should be added and divided by 2, because now when two coordinate points are given, the average of the two x values and the average of the two y values only should be found to calculate the coordinates of the midpoint. So in that case, it's going to be the average of the x values. So you add them and divide by 2, not subtract. Then we do add the y values together and divide it by 2. These three formulas are very, very important. Now the first one is to find the midpoint of CD. So we got to label the points here. So I'm going to label it as x1, y1, x2, y2. To calculate the midpoint, I'm going to use the midpoint formula, that is to find the average of the x values and the y values. Add x1 and x2. x1 is 5, x1 is 5, x2 is 13. Add 5 and 13. I need to divide it by 2. This will give us the average of the x values. I now need to add the y values, which is minus 1 and 15. Add them and divide it by 2. I'm going to solve this. 5 plus 13, and then I need to divide this by 2. So when I add 5 and 13 and divide it by 2, I end up getting 9, because it's 18 divided by 2. Next, minus 1 and 15 is going to be equal to 14. 14 divided by 2 is 7. So the midpoint will be 9, 7. So this is the coordinates of the midpoint. The next question is to find the gradient of CD. So we are going to make use of the gradient formula, which is y2 minus y1 over x2 minus x1. So in this case, to calculate the gradient, I'm going to use already we have labeled the coordinate points. So y2 is 15. I need to subtract y1. y1 is negative 1. So it's going to be 15 minus 1 over, I'm going to write the x values. So x2 is going to be 13 minus 13 minus 5. The value of x1 is 5. So this is what I need to write. I'm going to solve this. 15 minus 1 is 15 plus 1, that is equal to 16, over 13 minus 5 is equal to 8. This is the same as a 2. which means the gradient of the line connecting these two coordinate points will be a 2. The next question is a very, very important question. So in this question, we are asked to find the equation of the perpendicular bisector. This is a very important question. Now, to find the perpendicular bisector of CD, now we need to find the gradient of the perpendicular line first. Now, first we need to identify the gradient of the line CD, which we have already figured out, that is a 2. To find the gradient of the perpendicular line, we do the negative reciprocal of that gradient, which means now the gradient is given to us as a 2. The denominator of that is a 1 if there's no denominator given. To find the negative reciprocal of this means we flip the fraction, so it becomes 1 over 2, and change its sign. That means this 2 over 1, or this 2 is positive, we change its sign, so that's going to become negative, which means this will be the gradient of the perpendicular line. So I can form the first part of the perpendicular line's equation, which is y is equal to negative half x. I now need to find what this y-intercept is, which is c. So I'm going to write it as plus c. I need to find what this y-intercept is. Sometimes, like in the questions, mostly what happens is to find the value of this c, they give us a coordinate point mentioning that the perpendicular line passes through that particular coordinate point. A coordinate point will be given, so you would substitute the value of x and y into this half-completed equation, and that way we can find what c is. But in this question, a coordinate point is not given directly, but indirectly a coordinate point is given. That is, it clearly states that it is a bisector. The perpendicular line is a bisector as well, which means a bisector means it divides the line into two equal portions, which means in this case, for it to be a bisector, it means that it goes through the midpoint of the line. This is the most important part, which means we need to find the midpoint of this line CD that is mentioned here, and then that coordinate point only should be substituted for x and y to find the y-intercept. Already in the first step, we found the midpoint of CD, which means our perpendicular bisector is going to pass through this coordinate point, which is 9, 7. I need to substitute the value of x and y into this equation to find the y-intercept now. Because as it passes through the midpoint, that's why we had to substitute the midpoint here. So that's going to be 7 is equal to negative half times the value of x, which is 9, plus c. So this is the same as 7 is equal to negative 9 over 2 plus c. I'm going to take this to the other side. So this becomes y is equal to, this becomes 7 plus 9 over 2. So let me write it here. 7 plus 9 over 2, this is equal to the y-intercept. So when we add 7 and 9 over 2, we can put that in the calculator and see what we get. We end up getting the value of c as 23 over 2, or 11.5. Now we can write the equation of the perpendicular bisector, which is y is equal to, we know it's minus half x, that is the gradient, and we have x here. And the value of the y-intercept is 23 over 2, or I can write it as 11.5 here. This is the equation of the perpendicular bisector. This is a very important question. Now let's move on to the next question that we have. The next question is a question where a recurring decimal is to be converted into a fraction. Here, first you label this equation, this number that is given to us, which is 0.621 with the recurring 2 and the 1 as x. Next step is, I'm gonna times this x that I have here, or this equation, by a 10. So when I do that, x times 10 is 10x. Then when I times 0.621 recurring with a 10, that becomes 6.21 with the 2 and the 1 recurring. I times it by a 10 because I can have only the digits that are recurring after the decimal point. Next, what I'm going to do is, I'm going to times the same first equation by 1,000. So that becomes 1000x, which is equal to this. When I multiply by 1,000, it moves three steps to the right. So this becomes 621.21. And the 2 and the 1 is recurring. Here, the reason why how I know that we have 2 and 1 is because the meaning of this 2, 1 with the dots on top means that it goes as 0.6, 2, 1, 2, 1, 2, 1, 2, 1. Likewise, the 2, 1 keeps repeating. I times it by 1,000 because the digits after the decimal point should be the same. If I had times it by 100, it will be 100x is equal to, I will get 62.121212. Here the decimal part is not the same as this one. So when I subtract it, I cannot cancel it out. That's the reason why I had to times it by 1,000. Now when I do that, now I know that the decimal part that I have here is exactly the same. I need to completely get rid of the decimal part that I have here. So I'm going to subtract the equation that I have at the top by the equation that I have here. So when I do that, I get 1000x minus 10x, that is equal to 990x. This is equal to, now I have 621.21 recurring. I need to deduct this 6.21 recurring. So when I do that, I end up getting 600. Now from this amount, when I deduct it, I get 650. Now I need to find what x is. I need to divide both the sides by 990. So when I do that, I get the value of x, so which is equal to 615 over 990. But when I put that in the calculator, which is 615 over 990, I get it in the simplest form, which is 41 over 66. So if I check the answer as a decimal, I get 0.62122121, which is the same thing that is mentioned here, which means my answer is going to be, now according to this question, the answer that I ended up getting is 41 over 66. That is the fraction for this recurring decimal that is given here. Let's move on to the next question, which is question. Okay, so these questions are not in the order though. So these are from different past papers like I have picked, and you can see the code like I mentioned previously. Now in this question, we are supposed to calculate the area of this. We are supposed to calculate the value of x, and the area of this triangle is given. When we consider the area of the triangles, we have two formulas. One is area of a triangle is equal to half times base times height. Here the height is the perpendicular height. Now in this case, the perpendicular height is not known to us, so we cannot make use of this formula. So the other formula is going to be, to calculate the area of a triangle, is half AB sine C. In this case, the C that we have here is the included angle. So the included angle means it's the angle that is in between the two sides considered. This A and B will be those two sides. I'm going to make use of this formula to calculate the value of the angle, which is x. Let's substitute the values then. A is equal to 2143. That's the area of the triangle, which is equal to half times the value of A. I can consider A as 71. B as this 92.5, or I can even consider it the other way around, times the sine of the angle is x, so that's going to be sine x. I need to rearrange this to find what x is. So I have a fraction here. I'm going to take the fraction to the other side. This fraction is multiplying. When I take a fraction to the other side, instead of dividing the other side by half, what I could do is I can flip the fraction and multiply, which means I already have 2143. When I flip this half, I get 2 over 1, which is the same as a 2. Use that to multiply what I have here. So this 2143 gets multiplied by a 2. Then I have 71 and 92.5. They both are multiplying. So when I take it to the other side, they both will divide whatever I have here. So that's going to be 71 and 92.5 divides the amount that I have in this side. this will be equal to sine x. But I need to find what x is. X is an angle. To calculate the value of the angle, I need to do inverse of sine, and then whatever the calculation that I have here should be written. That is 2143 times 2, and then I have 71 times 92.5. I'm going to put this in the calculator, and then I'll be able to find the value of the angle. So then I'm going to do inverse sine. Then I need to do 2143 times it by 2 and divide it by 71 times 92.5. I'm gonna close the brackets, and the value I get is 40.738. So correct 2 decimal places, it's going to be 40.74 degrees. I can also write it to 3 significant figures. Now, the next part is, now the next thing that I wanted to really explain here is, now we have found the value of x. There are instances where they could give you a question like this, asking you to find the angle, but they would mention it as to find 2 possible values for that particular angle. Which means, just like we did, we will find one angle, but when they ask for 2 possible values, to calculate the other value, now this is an acute angle. To calculate the other value, you can find its obtuse angle. That means, to find the other angle, which is the obtuse angle, I need to do from 180 degrees, we will have to deduct the angle that we have here. That will give us the obtuse angle. The reason is because the obtuse angle, and there can be instances when they could have 2 different angles, but the 2 sides will be the same, and when we calculate the area, it will be equal as well. In the question here, the diagram is given, so we know that this is an acute angle, so we can just find what x is and leave it like that. But if the diagram is not given, and if they ask us to find the values of x, or if they say to specify, if they specifically mention asking us to find the obtuse angle that it could be, then we definitely have to calculate the obtuse angle. Then let's move on to the next question that we have. This question is a question that is related to algebraic fractions. So here, write as a single fraction in its simplest form. I'm going to make a small change here. That is, instead of doing the addition, let's change it into subtraction and do, because addition is fine. Subtraction is slightly tricky. Now, when we have 2 fractions given like this, where we need to subtract, now, even if it's not involving algebra, when adding or subtracting, it's important that the denominators are the same. So we have to make the denominators the same. In this case, to make the denominators the same, I would multiply the first fraction's denominator with 2x minus 1, and its numerator also with 2x minus 1. Then the second denominator that I have here, which is 2x minus 1, I need to times it by this one's denominator, which is 3x plus 2. I need to do the same thing to its numerator as well, because whatever the change that I do to the denominator has to be done to its numerator as well. This way, I know that they both have the same denominator, which is 3x plus 2 times 2x minus 1. I have 2x minus 1 gets multiplied with this 5, so I can write it as 5 times 2x minus 1. I have this 4, and it gets multiplied with this 3x plus 2, but it gets subtracted. So I'm going to write it minus 4. But it's very important that I put the brackets. If we do not put the brackets, there are very high chances that you end up getting an incorrect answer. So here, both the terms that we have here gets multiplied by this 4 and gets subtracted as well. So what I'm going to do is, I'm going to multiply by a 4, at the same time do the subtraction both at once. So that is, I'm going to do it as minus 4 times 3x minus 4 times 2. So first, let's expand the first brackets that I have here. So I have 5 times 2x, that is going to be 10x. 5 times minus 1, which is minus 5. Minus 4 times 3x, which is minus 12x. Minus 4 times 2, that is going to be minus 8. over the denominator, which is 3x plus 2 and 2x minus 1. Now, now we need to understand that the denominator is not going to be expanded. When adding, subtracting, dividing, or multiplying algebraic expressions, there's no need for us to expand the denominator. But if it's an equation where it's being equal to a fraction or a number or a variable, in that case, we need to expand the denominator as well when trying to solve an equation, an algebraic equation. So here, the denominator has to be in the form of factors. So now I'm going to combine the like terms, which is 10x minus 12x, that is equal to minus 2x. Then I have minus 5 and minus 8, that is minus 13. This is over the fraction, over the factors given here, which is 3x plus 2, and then 2x minus 1. This is going to be the answer for this question. Here, there is no need for us to factorize the numerator even though the first term is negative, because usually when we have when the first term is negative, it's when we are supposed to factorize it, we can factorize it by taking out the negative and putting the rest within the brackets. But let's say, for example, we have a question like this. It says we have something like minus 2x plus 1, and let's say we have over this 3x plus 2 times 2x minus 1. In this case, it's very important that we factorize, because when we factorize this, I would take the minus out and the terms that go inside the brackets will be 2x minus 1 over this 3x plus 2, and then I have this 2x minus 1. If I don't factorize it, I won't be able to simplify this. But here, only after factorizing it, I can simplify these two, leaving the answer as minus 1 over 3x plus 2. So in a question like this, where when we factorize it, if we can simplify it with the denominator, it's very important that you factorize it. But in this case, even if I take the negative out, I get 2x plus 13, which cannot be factorized. So I can leave it like this. Let's move on to the next question that I have written in the side here, which I have put in the side here. Now here we need to simplify it. So to simplify this expression that is given to us, now we have 2x squared plus 5x minus 12 over 4x squared minus 9. The numerator is a trinomial. We have 3 terms. So in this case, to solve it, now the number in front of this x squared is a 2. I times it with the number at the back, which is negative 12. So 2 times negative 12 is 24. So I need to find the 2 numbers that multiply together to give us negative 24. And when added together, it has to give this positive 5. So the 2 numbers that multiply together to give us negative 24 and add together to give us 5 is 3 and 8. And the 5 is positive, which means I need to make 8 positive and this 3 negative. Only then when multiplied, we still get the negative 24. And when added, we get positive 5. Now here, the terms that we have is 2x squared plus 5x minus 12. The 2 numbers that we have found here is used to replace the term in the middle with 2 terms, which means this will be 2x squared minus 3x plus 8x, and I have this minus 12. Now what I'm going to do next is, now I have 4 terms, I need to start pairing it, and I'm going to factorize it by taking out the common terms. So I can take x out, this becomes x minus 3, and I can take plus 4 out, again this becomes x minus 3. These 2 brackets will be the same. Write that once, and the terms that are left outside the brackets are combined and written together in another bracket like this. Here, we cannot use the direct method because the coefficient of x squared, that is the number in front of x squared, is not a 1. If it was a 1, now let's say this was given as x squared, and without giving it as a 2, let's say it was given as a 1, then there is no need to multiply. Even if you multiply, it will be negative 12. So we would find the 2 numbers that multiply and make negative 12 and add and make a 5. As soon as we find the factor pairs that multiply and give us negative 12 and 5, we can put it within the brackets with x itself. Directly, we can do it that way. But here, as we have a coefficient in front of this x squared, that is a number in front of x squared, we have to make use of the long method. Now, according to this question, we know that the numerator, the factors for the numerator is x minus 3 and x plus 4. Now, in the denominator that I have here, we have 4x squared minus 9. So that is the difference of squares. So difference of squares is something very important as well. Now here, the way how we identify if they are the difference of squares is, now we have x squared, we have minus 4 and 9, they both are square numbers as well. All the terms are squares or square numbers, and we have a minus. So we call that as the difference of squares. In this case, we have 4x squared minus 9. When factorizing the difference of squares, we need to do it like, it's going to be like this. We need to, as if it's going to be all the terms in the numbers, all the terms in this expression are square rooted. So it will be 2, x squared is going to be x when square rooted, square root of 9 is going to be a 3. Put this 2x and 3 in 2 brackets, one of the bracket with a minus, the other bracket with a plus. Sometimes we will have to take out a common term and then we will have to do the difference of squares. But here, as all the terms given here are square numbers or squared variables with a minus, we can directly square root and put them inside the brackets like this, but into 2 brackets with a minus and a plus. I'm going to put that in the denominator. So I have 2x minus 3 times 2x plus 3 as the denominator. Now what I can do is, I can see if I can, we can see if we can factorize this. So in this case, we have 2x minus 3 and, okay, I think I missed a 2 here. So here, when I take the, x out, it should be 2x. So this is going to be 2x as well. So the first one will be 2x. So this is 2x minus 3. I'm so sorry about that. It should be 2x minus 3. Now I'm going to simplify this. So when I simplify, this gets crossed out with this, leaving us with this answer, which means this x plus 4 over 2x plus 3 is our answer for this calculation given. Let's move on to the next question that we have. The next question is a question related to bounds. This is a very important question as well. So in this case, the train travels between 2 stations. The distance between the stations is given to us to the nearest kilometer, and the speed of the train is given to us to the nearest 5 km per hour. The way how we understand if it's a question related to bounds is, they would have mentioned the amount correct to a particular decimal place or to a particular significant figure. That is how we know that it's something to do with bounds. And here in the question also, it's mentioned that it's something to do with the bounds because we are asked to calculate the upper bound of time. Now, this is a question related to speed and bounds. So the formula to calculate the speed is distance divided by time. But here we need to calculate the time. To calculate the time, I need to switch these two. So time is equal to distance divided by speed. But I need to calculate the upper bound for speed, upper bound for time. So then to calculate the upper bound for time, that is like the largest possible value this time could take. So if I'm to find the upper bound for time, the value of d that I have here should be the upper value, the upper bound of d, or the maximum value of d, and speed should be the lower value. Only then we can form the largest possible value. We can get the largest possible value for t, or the upper bound for t. Now, if they ask us to find the lower bound of t, in that case, d will be the lower bound. The speed will be, we need to substitute the upper bound of speed to calculate the lower bound of t. Now we are asked to find only the upper bound, so this is what we do. Now, the distance is given to us as 220 kilometers. I need to calculate the upper bound for distance. So it's been rounded to the nearest kilometer. Nearest kilometer means the nearest whole number, that is to the nearest ones, if I'm to say. So that 1 has to be divided by 2. Always the number to which it's being rounded has to be divided, the place value for which it's being rounded has to be divided by 2. So 1 divided by 2 is 0.5. That is the number that is added or deducted to find the upper bound or the lower bound. So deducted to find the lower bound, added to find the upper bound. We need the upper bound of distance. So I need to add the 0.5 to this 220. That's 220.5 kilometers. Next, I have 125 kilometers per hour, and it's being rounded to the nearest 5 kilometer, which means that 5 has to be divided by 2, which is 2.5. This is the amount that is added or deducted to calculate the upper bound or the lower bound. Here, I need to find the lower bound for speed. So I just need to find only the lower value. So I need to deduct 2.5 from this 125, which is 122.5 kilometers per hour. I'm going to substitute it here now, which is equal to, the distance is going to be 220.5 over, speed is going to be 122.5. But here, the distance is going to be in kilometers. The speed is going to be in kilometers per hour, which means the answer that I get will be in hours. I'm going to put this in the calculator. So I have 220.5 in the numerator and 122.5 in the denominator. When I do that, I get 1.8. This 1.8 is going to be 1.8 hours. But the question isn't asking us to calculate in hours only, but hours and minutes. So we have this button in the calculator where we can convert this 1.8 into hours and minutes. So we can simply press that button to find how many hours and how many minutes it will be. Or this 1.8 should be times by 60. You would completely convert it into minutes. And then you will check how many 60s are there to check how many hours, and the rest will be the number of minutes. In this case, I'm going to use this. That way I know it's going to be 1 hour and 48 minutes. So this is equal to 1 hour and 48 minutes. This is going to be the upper bound for the time. Let's move on to the next question that we have. This is a question that is related to speed. We can expect this as well. Now, in this question that is given to us, and it cycles a distance of 70 kilometers from Midville to Newtown. Leaving Midville, she cycles for 1 hour and 30 minutes at a constant speed and stops for 30 minutes. She then continues the journey to Newtown at a constant speed of 16 kilometers per hour. The first step is to complete the grid, that is to draw the distance time graph on the grid. To do this question, now she goes from Midville to Newtown, which is, she cycles a distance of 70 kilometers, which means Newtown is 70 kilometers away from Midville, which means this is where she's going to start. So this is Midville, I'll label it as M. 70 kilometers is going to be here because this is 60, this is where 70 is. This is where Newtown will be. Now, what we got to do is, in the question it clearly states that she cycles for 1 hour and 30 minutes at a constant speed of 20 kilometers per hour. Now, we know that the speed formula is distance divided by time. So then, the speed is 20 kilometers per hour. The time is known to us. We can calculate the distance. To calculate the distance, the speed and the time has to be multiplied together. Speed is going to be 20 kilometers per hour. Times it with the time. 1 hour and 30 minutes is the same as 1.5 hours. So I need to times it by 1.5 to calculate the distance. This distance that I get will be in kilometers. So 20 times 1.5 is 30. So 30 kilometers is the distance traveled at this constant speed, which is traveled within 1.5 hours. That means 1.5 hours is here. They travel 30 kilometers. 30 is going to be here. So then I need to mark this point. That means from within this is 1.5 hours, they're going to travel in 1.5 hours, they're going to travel 30 kilometers. So the diagram will be like this. They travel at a speed of 20 kilometers per hour. Next, she stops for 30 minutes. So that means from 1:30 to 2, she's going to be, she has stopped. Then the next one is, she then continues the journey at a constant speed of 16 kilometers per hour. Now the speed is given to us. Then in the question, we know that she is going to travel at this speed until she reaches Newton, which is from this distance. If we check how far it is, from 35 to 70. So this is going to be the distance. So we need to find that difference first. So that's going to be the difference between 70 and this is not 35, this is 30. That's going to be 40 kilometers. So that is from wherever she is at the moment, from there, she has to travel 40 kilometers to reach Newton. But we do not know how much time is taken. That is what we are supposed to find now. So speed is equal to distance over time. If I'm to calculate the time, I need to swap this speed and time. So time will be equal to, now I will write it here at the bottom. So time will be equal to distance over speed, because I'm going to swap these two around. That means the distance traveled from here to Newton, which is 40 kilometers, has to be divided by the speed. Speed is given to us, which is 16 kilometers per hour. So 40 divided by 16 gives us 2.5, which means she reaches Newtown from wherever she is at this at 2 p.m. in 2.5 hours, which means from 2 o'clock, 2.5 hours means it's going to be 4.5 hours or 4:30. Then at this point, at 4.5, that is when she just reaches Newtown. So this is going to be 4.5 is here. So I'm gonna connect it to this point. Connect this one here, just like this. This is how the diagram would look like. Then the next question is to calculate the average speed of the whole journey. To calculate the average speed, we know that speed is equal to total distance over time. So average speed will be the total distance divided by total time. The total distance is from Midville to Newtown. It's going to be 70 kilometers. So 70 divided by the total time taken is from 0 to 4.5. That's going to be 4.5 hours. So 70, we got to divide it by 4.5 hours. When we do that, we get about 15.56 kilometers per hour. This will be the average speed. Now, this is going to be a distance time graph. But if we have a speed time graph, now in that case, if we are to calculate the distance traveled, in that case, the area under the graph will give us the distance traveled. That is another point that we need to understand. Let's now move on to the next question that we have. This question is a question that is from the core paper, but I decided to pick this question is because this is a question related to currency where two different currencies are involved in this question. So we will have to do the currency, we will have to exchange it, we will have to convert it twice. That's the reason why I had to pick this question. Now, in this question that is given to us, Vani changes X euros into dollars. She then changes the dollars into rupees and she gets 17,850 rupees. We need to find the value of X. So to find the value of X, what we could do is, now first, the euros is converted to dollars. So euros to dollars is going to be this one. I'm going to write this in the form of a fraction as 1 euro over 1.015 dollars. I have put the euros at the top, dollars at the bottom. I need to put an equal sign and write the euros at the top and dollars at the bottom. If I write dollars and dollars at the top in the numerators, both the euros will be in the denominators. I need to write it this way. I know that the euros is going to be X euros that I need to calculate. And the amount of dollars is what I do not know how much that how many dollars I get for this one. So I'm going to put a question mark here, and I'm going to find how much that is. So to do that, I need to cross multiply 1 times whatever the amount that we have here. There's no amount, so it's going to be the same one. So then to find this amount here, I need to multiply this 1.05 with this X. That becomes 1.05X. We can forget about all these currency symbols. So this amount is going to be 1.05 times the number of euros, because X is the number of euros. This will give us the answer in dollars. Now I have converted into dollars. Now the next step is, now according to the question, they have given us how many rupees this is. So there is a relationship between the rupees and dollars. That is, 1 rupee is the same as $0.013. I'm going to put this in the form of a fraction, just like I did here. So I'm going to write rupees here, 1 over the dollars, which is going to be 0.013. I'm going to relate this with the number of dollars that we have here. So this is equal to, and I know how many rupees this is, that is 17,850 rupees. So as I have written the rupees in the numerator, I need to put the same 17,850 also in the numerator, because only then both the rupees are in the numerator. Then the dollars should be written at the bottom. We know how many dollars this is, which is 1.05x dollars. I'm going to do the same thing that I did here, which is to cross multiply and make X the subject. I'm going to cross multiply. 1 times this 1.05x is the same 1.05x. This is equal to 0.013 times 17,850. Now, for me to find what X is, I need to divide this side by this 1.05. So I'm going to put that in the calculator. So I have 0.013 times 17,850. I find the amount. And then I can divide it by 1.05, or directly I can put it in the calculator as well. So this gives me 221, which means the value of X is $221. This is going to be the amount, 221. I'm sorry, this is not in dollars. This is euros, because the value of 1.05x is in dollars, but this X is going to be the number of euros. So this is going to be this many euros. So this is an important question as well. Now let's move on to the next question that we have, which is question 26. This is a very important question, which is related to vectors. At the same time, this involves similar shapes as well. So that's why this question is very important. So now in this question that is given to us, we are given a parallelogram OPQT. The position vector of P is given to us as A. Position vector means from the origin, how far away it is. So here O to P is only given as position vector of P, means O to P is given to us as A. And the position vector of T means O to T is given to us as B. Now K is here, O to K, P to K and K to Q's ratio is given to us as 3:1. So I'm going to write it like this. And this line PK and this line OK is, PK and this line TQ is extended to meet at X. Now we need to find the position vector of X. So this is where X is. Position vector of X means I need to find what O to X is. That is what the question is asking us to find. Now, for me to do this question that is given here, first I am going to find what P to Q is. P to Q is the same as O to T that we have here. So that will be P to Q will be the same B. Now I'm going to find, now I have a ratio that is given, so I can find how much this portion is. So the total is, it's split into 4 and 3 portions out of it, which means this portion that we have here is 3 plus 4, 3 plus 1 is 4. So this portion is 3/4 of P to Q. P to Q is B, so P to K will be 3/4 of B. The same way, K to Q also can be found, that is one portion out of 4 portions. That means it's going to be 1/4 of P to Q. So P to Q is the same as O to T, which is B. So I can write it as 1/4 B. Now, I need to find what O to X is. I do not know what QX is, or I do not know what KX is. Because of that, because of that only, I cannot solve this if I don't use similar shapes, similarity of shapes for us to work this one out. So in this shape that is given to us, we know that this is a parallelogram, which is OPQT is a parallelogram. That's already mentioned in the question. So the opposite sides will be parallel to each other. At the same time, the vectors will be the same vectors. In this case, I'm going to prove that this triangle and this smaller triangle that I have here are similar shapes. To do that, this angle and this angle will be equal because they are vertically opposite to each other. So I have drawn the two shapes separately, so I'm going to mark it here as well. So this one and this one are equal. Next, I have this angle and this angle will be equal. The reason why we have these two angles, why these two angles will be equal will be, if I draw the Z shape like this, they will be equal. They are alternate angles. Therefore, this angle and this angle that I have here are equal. Then the next one that I have is this angle. So I'm gonna mark it here in yellow. This angle will be equal to this again because of the Z shape here, because they are alternate angles, they will be equal. Now, I know that 3 angles in this triangle is equal to the 3 angles in the other triangle, which means the two triangles are similar shapes. Similar shapes mean that the angles will be equal, the matching angles or the corresponding angles will be equal. At the same time, the ratio of the matching sides will be equal. Which means if I consider the ratio of the matching sides, first I will mark all the sides vectors given to us. So O to P is A, that's already marked here. Then we know what P to K is. This is 3/4 B or 3/4 B. Then we know what this is. This is going to be K here. K to Q also we know that's going to be 1/4 B. Now, if I need to find what O to X is, because I need to find the position vector of X. So for me to find what O to X is, I'm going to use this vector O to K and K to X. So I'm going to add O to K and K to X. Now, if I add these two together, that will be equal to O to X. O to K is the same as A and then plus this 3/4 B, because 3/4 B is going to be from P to K. So O to K is A plus 3/4 B. So I'll write it here. At the same time, I can put it here as well, A plus 3/4 B. So I know what O to K is, which is A plus 3/4 B. Now I need to find what this K to X is. For that, we need to make use of similar shapes. Now, the way how I would do this is, now O to P, if I consider the side O to P, let me write it here. So this side O to P is going to be this side, that is the side that is connected to the angle in blue and yellow, is matching with this side QX. So I can, I'll get rid of this line at the top and write it as just OP over QX. Those are the matching sides. So I have written the larger triangles values at the top, side at the top, and the smaller triangles side at the bottom. This ratio will be equal to the ratio of the other matching sides as well, which means I can say that this is the same as, in the other side, I can consider this side, which is P to K. So I'm gonna write P to K over The side that is matching with this P to K is this side that I have here. So that is going to be KQ. So these two sides are matching because they are the corresponding sides, which are the sides that are connected to the angle that I have marked in purple and yellow. These two's ratio will be the same as the ratio that I have here. So the ratio that I have here is P to K is 3, K to Q is 1. So I can write it as 3 to 1. I can write it this way. Which means now in terms of B, if I'm to say, in that case, now I can just write it this way as well. So P to K is equal to K over Q. And this is also equal to, I have another side as well. So I will put the other side right next to this one. Okay, I'll leave it like this itself. Okay, I will write it here. The other side that is we have is OK and KQ. OK and KX, I'm sorry. So I can write it like this. Now they have the same ratio. We know that here 3 over 1 is the same as OK over KX, which means I'm going to cross multiply this and find what KX is. So that is KX. I have the value here, the ratio here, which is 3 to 1. KX will be, to find that, I need to first multiply with the 3. 3 times KX is equal to 1 times OK, that is OK. Then if I'm to find what KX is, I need to divide this OK by 3. O to K's ratio, O to K's vector is already known to us as A plus 3 over, this is equal to A plus 3 over 4B, because that vector is already known to us because we found what O to K is, what O to K is previously. So O to K is A plus 3 quarter B. This should be divided by 3, which means 1A also has to be divided by 3. 3 quarter also should be divided by 3. 1A means we have a 1. 1 divided by 3 is a 3. So that is the same as 1/3 A. Then we have 3 quarters. I need to divide that also by a 3. So if I write 3 quarters and if I divide this by a 3, I get a quarter. So that will be the same as a quarter B. So I can write this as a quarter B, which means, and now I know what K to X is, that is going to be 1/3 A plus quarter B. So when I simplify this, this is what I get. So I have, instead of writing it here, I have written it here directly. Now I need to add these two together to find what O to X is, which will be the position vector of X. I have A here, and I have 1/3 A. 1A and 1/3 A, so this is 1 is a whole number. 1 whole and 1/3 is going to be 4/3. So I can put it in the calculator and show as well. So that is 1 plus 1/3. So 1 and 1/3 when I add, it's going to be 4/3. So I can write it as 4/3 A. And then I have 3 quarters and a quarter. When I add, that becomes 1 whole. So that is 1B, or I can just write it as a B. This is that vector O to X, or the position vector X that we are supposed to find. This will be our answer. This is a very important question where this involves similar shapes as well. So this we are done with this one now. Now let's move on to the next question that we have, which is question 21. In this question that is given to us, so let me get rid of this part here. This is something that we had in the previous question that we did. So let's work on this question. In this question, so you might get a question like this as well, because now there are questions that come up with this 3D shapes where we are supposed to find the angle or the missing side lengths. So likewise, we will have to make use of 3D shapes, Pythagoras' theorem and trigonometry to work out questions like this. So first, let's read the question that is given to us. So here the question is that The diagram shows a cuboid ABCDEFGH. AB is 14 centimeters. Then the other side given to us is BC, which is 5 centimeters. CG is 8 centimeters, and M is the midpoint of HG. So this is where M is, that is the midpoint of HG. And we are supposed to find what BM is. This is BM. To find what this BM is, this is what we are going to do. So I'm going to first use this side, and I'm going to calculate how much BG is. Once when I calculate what BG is, I'm going to calculate what BM is. So to do that, this BG that I have here is going to be the hypotenuse for the two sides given here, which is 5 and 8. So I'm going to find the hypotenuse, means I need to square them, add them together, and square root it. If we are trying to find one of the shorter side, means from the square root or square of the hypotenuse, I need to deduct the other side square and then do it. But in this case, of course, I need to do 5 squared plus 8 squared and then square root it. So this will give us the value of BG. So the value of BG is equal to, so I'm going to put this in the calculator. So square root, we have 5 squared and then 8 squared. So when I do that, I get square root of 89. So that is equal to BG. And if I want, I can write it as 9.43 as well. So I'll just leave it as square root of 89 because we're going to make use of this to find what BM is. So now if I'm to find what BM is, now that I know how much this side is, I can consider this triangle now. So this one will be a right-angled triangle. Now, in this case, if I'm to find what BM is, so I need to apply the Pythagoras theorem again to find what BM is. So for me to work this one out, in this case, this side is known to us. Now, M is the midpoint of HG that is mentioned in the question, which means this side is 7, this side is 7. Therefore, for me to find how much this is again the hypotenuse for this triangle. So I need to square the 7, square the value that I got here. So I already got square root of 89. So I can put the square root of 89 and square it, or we can write the decimal answer and then square it. And then this entire thing should be square rooted for me to find what BM is. So when we do that, so I'm going to put this in the calculator as square root of 7 squared and the previous answer square. I'm adding them here because we're trying to find the hypotenuse, because BM is the hypotenuse. When I do that, I get the square root of 139, which is 11.747. So corrected 2 decimal places, it's going to be 11.75 centimeters. This is the value of BM. Now let's move on to the next question that we have. Now here, we need to calculate the angle that BM makes with the base ABCD, which means this is that side BM. It makes with the base, means in this case, I'm going to draw a line, a perpendicular line from M to this side. So this is the base that we have here, which is ABCD. So I'm going to connect it this way. So this is a 90-degree angle. So the side BM makes with the base, means this side BM makes with the base, means this is the angle that they're asking us to calculate. So I need to find that angle. I'm going to label this angle as theta, or we can even label it as X. So I need to find what that angle is. So for us to find that angle, this side is the same as this side, which is 8. And I need to find this angle. So this 8 is the opposite side, whereas now this side that we have, which is B to M, is already known to us. Now we found it previously, which is 11.75. This 11.75 is the hypotenuse for this triangle. So I can use this right-angled triangle using SOHCAHTOA. I can find the value of this angle, which is theta. That means when we consider SOHCAHTOA, The trigonometric ratio that involves the opposite side and the hypotenuse is sine, which means I'm going to use sine theta for this to calculate the value of the angle here. So it will be sine theta is equal to the opposite side, which is 8, over the hypotenuse, which is 11.75. So again, here we are trying to calculate the value of the angle. So I need to make use of inverse sine of 8 over 11.75. This will be the value of the angle. So I'm going to put this in the calculator and let's see what we get. So we have inverse sine and we have 8 over 11.75. So this is equal to 42.91. So then the value of the angle that BM makes with the base is 42.91 degrees. Let's move on to the next question. In this question that is given to us, okay, now we are supposed to find the coordinates of the point where this line, which is 4x plus y, intersects the curve y plus x squared is equal to 5. You must show all your working. Now, in this question, usually simultaneous equations are given to us directly. They will give both the equations. So we have simultaneous equations that are just using straight lines, which are linear simultaneous equations. And we also have simultaneous equations involving quadratics, like this question. Now, they would give it to us in a sentence like this, but indirectly, we are asked to solve the simultaneous equations here. So the two equations given to us are the simultaneous equations given, which are 4x plus y is equal to 9, and we have 9 plus x squared is equal to 5. We need to solve this. So I'm going to make y the subject in the first equation. So I'm going to take the 4x to the other side, so it gets deducted from 9. So y is equal to 9 minus 4x. I'm going to substitute this equation here. And when solving simultaneous equations involving quadratics, the substitution method is always the easiest method. So we can use the other methods as well. That's absolutely fine. That is the elimination method. We can use it, but substitution will be much more easier, and it can be used for almost all the simultaneous equation that involves quadratics. I'm going to substitute it here. So I have 9 minus 4x plus x squared is equal to 5. I'm going to bring the 5 to the other side because I know that this is a quadratic equation. So when solving quadratic equations, it's important that I make the equation equal to a 0. I'm going to bring the 5 to the other side. So I have x squared minus 4x. I'm rearranging it as well. So I'm going to put the x squared first, minus 4x. I have a 9 already. I'm going to bring the 5 to the other side. That becomes minus 5. This is equal to a 0. I can simplify this. So that is x squared minus 4x plus 9, and minus 5 is equal to plus 4. This is equal to a 0. Now, this quadratic equation can be solved using the factorizing method or the formula method, or we can also solve it using the completing the square method. Here we can directly make use of the factorizing method as well, but in the question they haven't mentioned, and they usually don't mention which method to use for a simultaneous equation. But in this case, I'm going to make use of the quadratic formula so that I can give you an idea of how to make use of the quadratic formula. Always the equation has to be made equal to a 0 when using the quadratic formula, or even the factorizing method, or even the completing the square method. It's always important that we make the equation equal to a 0. Now, when it comes to quadratic formula, if we are to use the quadratic formula to solve it, a quadratic equation is of the form ax squared plus bx plus c, which means a is the value in front of a, which is 1, b is negative 4, c is 4. So a is 1, b is negative 4, c is 4. And the quadratic formula will be given to you, but here I'm going to write it, which is minus b plus minus, and within the square root, I have b squared minus 4ac. This is over 2a. I'm going to substitute the value of a, b, and c into this. The value of b is -4, so that's going to be minus 4 plus minus square root, and then the value of 4 is again -4 with the square, -4 times the value of a is 1 times the value of c. The value of c is 4, and then I'm going to write this over 2a. That's going to be 2 times the value of a, which is 1. I'm going to put this in the calculator and let's see what we end up getting. So then when we put this in the calculator, so we have, I'm going to put the fraction here. Okay, we have minus 4. So minus 4. And inside I have the plus square root. Then inside this, I have -4, close the brackets, put the square, -4 times the value of a times the value of c, that was a 4, over 2 times the value of a, which is a 1. When we solve this, we get the value of x as a 2. Now, we got to do the same thing with the minus as well. So I'm going to move this and change this plus that we have here into a minus and see what we get. Even when it's a minus, we get a 2, which means as this gives us the same value for x, which is 2, we can understand whether when we have a plus or a minus, we both end up getting the same value, which is a 2 for x, which means that gives us an idea that we have on the one coordinate point, that is the graph, the quadratic graph, and the straight line graph, it intersects at just one point. For example, if the graph is like this, and if we have a straight line like this, it just intersects at 2 points. But in this case, it's going to intersect like something like this. Maybe it could be like a tangent like this, where it hits the graph at just 1 point like this, or it could be a line that goes like this. So it can be any of the two lines like this. It could be like this, or a decreasing graph. Somewhere it meets the curve at just 1 point. That's the meaning. Now that I know the value of x, I need to find what y is. I'm going to substitute the value I found for x into the equation that we rearranged, or any of the other two equations as well. So we have y is equal to 9 minus 4x, that is 4 times the value of x, which is 2. 9 minus 4x, that is 4 times 2, that is equal to a 1. So the value of y is a 1. So I can write the value of x and y together in the form of coordinate points as 2 and 1. This is what we get as the answer for this question. Let's move on to the next one that we have, which is a question that is related to transformations. Now here, the main reason why I picked this question is to give an idea about negative scale factors. So in this case, the first question is to explain the symbol transformation that maps triangle A onto B. A onto B is going to be reflection, because it's being reflected about this line. We need to write the line of reflection when explaining it. So this is, it goes through, the line is y is equal to 2, because the straight line that we have drawn here, it goes through the y-axis at 2. So when we explain it, we put to explain it as, this is reflection on y is equal to 2 line. The next one is to rotate the triangle, the shape A. This is not a triangle, I'm sorry. This is a quadrilateral. This is rotated 90 degrees clockwise about the point -1 and 2. -1 and 2 is here. This has to be rotated clockwise 90 degrees. So when we rotate clockwise, it has to go this way. So we need to find the location of the shape of the image once when it's being rotated 90 degrees clockwise. To do that, we place the tracing paper on the grid. You can make a small mark at the top of the tracing, at the top on the tracing paper. So when we do a 90-degree rotation, clockwise rotation, the mark that you made at the top will move somewhere to this side. Then the next one is, that is how we know it has done a complete, it has done a 90-degree rotation. You need to hold the pencil point at -1 and 2 when you rotate it. But before that, we need to draw the diagram A on the tracing paper. And once when we draw it and rotate, the image that we would end up getting will be like this. It will be here. We will have at -6 and -5. Then the one coordinate point will be here, and the other one will be at this point. So it's going to be somewhere here. So this is how it will look like after a 90-degree rotation about this coordinate point that is given. The next part of the question is to enlarge shape A by a scale factor of -2 about the center 2, 0. 2, 0 is going to be this point. We need to enlarge by -2. This 2 explains that the enlarged shape that we get is going to be larger in size. This negative explains that it has to be enlarged in the opposite direction. That's the meaning. Which means, now first, to do the enlargement question, this center of enlargement and each of these vertices should be connected with a straight line. So I'm gonna first draw a line connecting this vertex and this one, this point here, the center of enlargement. This is how it will be. So this is going to be one diagonal unit away. So the scale factor has to be -2. So in the opposite direction means in the other side of the center of enlargement along this line, this same distance, I need to double it. So it's going to be here, which means my first point will be here. This vertex will be enlarged here, will be here. That's the meaning. Then I'm going to do the same thing for the other points as well. So I'm going to consider the other side that I have. So let's say I'm going to pick this side. So this is how it's going to be. So I'm going to extend it like this. This is going to be 1 unit, that complete 3 boxes is considered as 1 unit. We double it. So 1, 2, but in the opposite direction. Therefore, it's going to be here. Then the next one that we have is this one. I'm going to connect this again. That goes through the center of, okay, I'm so sorry about that here. I have made, consider this as the center of enlargement. It should have been this one. Okay, so this is how I should have drawn it. And then this amount should be doubled. So it's going to be here. So I'm going to mark that point here. Then the next one that I have is this point. It should go through this. So it's going to go like this. Then I have this. Okay, this is how it's going to be. So this distance is like 2, 3 units. 2 across 3 units. 3 up. 2 across 3 up. 2 across 3 up. I need to do it twice because I need to enlarge it by a scale factor of -2. So it's going to be here. So this is where this vertex will be. So I have identified the location of 3 vertices, but I have one more vertex, that is this one. So I'm going to do the same thing. This should go through the center of enlargement, which is this one. So that's going to be like 4, 3. So it's going to be 4, 3, 4, 3. It's going to be something like this. So let's check this one out. It's going to be 4 units and 3 up, 4 units and 3 up, 4 units and then 3 up. So it's going to be this point here. Now what I got to do is I'm going to connect all these vertices together. So when I do that, this is how it will be. So these two should be connected. Then the next one that I have is this point should be connected to this vertex that we have here. Then this should be connected to this vertex. And then this point should be connected to this. This is how our enlarged diagram will look like when there is a scale factor of -2. So you can see this is the center of enlargement. The enlarged diagram is in the opposite side of it, as the scale factor is negative. Now let's move on to the next question that we have. Question 11. So there are two shapes given to us. They are similar shapes. We need to find what QR is. So that is this side. So when we consider these two sides given to us, this is 8 and 6. So those two are the matching sides. So matching sides should be written in the form of a fraction. So I'm going to write the larger triangle's value at the top and the smaller shape's value at the bottom. So that's going to be 8 over 6. The matching sides should be written. So that's going to be 8 over 6. And then I need to relate it with the side that is given and the side that we are supposed to find. So in this case, it's going to be 6 over the value. So 6 over, I'll write it as QR itself. I need to find what this QR is. Then I need to cross multiply to find what QR is. So the value of QR will be 8 times QR is equal to 6 times 6. So for me to find what QR is, 6 times 6 is 36, should be divided by 8. So when I divide 36 by 8, I get 4.5 centimeters. That is the value of QR. The next one is something important. Here, the two shapes, the two triangles, are the cross-section of two mathematically similar prisms. Still, the shapes are, the 3D shapes that we get are mathematically similar. The volume of the larger prism is given to us. We need to calculate the volume of the smaller prism. This is something very important as well. Now, the scale factor between of this linear, the larger shape and the smaller shape is equal to this 8 over 6 that we wrote here, but we can simplify and write. So when I simplify this, this becomes 4 over 3. This 4 over 3 is the linear scale factor. I need to find the volume of the larger shape. In that case, for me to find the volume of the larger shape, what I'm going to do is I need to find the volume scale factor. So I'm going to cube this. So when I cube this, I get 4 cubed over 3 cubed. So 4 cubed is going to be equal to 4 times 4 times 4, that is 64, over 3 cubed is equal to 27. This is the volume scale factor that I need to relate it with the volume given. So the volume of the larger shape is given. Large shape's value is the one that is written at the top here in my scale factor. So I'm going to write it as 320 at the top. And I need to find what is at the bottom, that is the smaller shape's volume. So I'm going to label this as V. I'm going to cross multiply to find what this V is. So when I cross multiply, I do 64 times V. So 64 times V is equal to this 320 times 27. Then I need to divide it by 64. So when I divide it by 64, I get the value of V. So the value of V is equal to 320 times 27. And when I divide it by 64, I end up getting 135 cubic centimeters. This is the volume of the smaller prism that is mathematically similar to this larger prism, which has a volume of 320 cubic centimeters. Now let's move on to the next question. Here, a map of a scale 1 to 25,000 is given to us. This is something to do with area, because the area of the lake is given to us as 33.6 square centimeters. And the actual length of the lake is what we are supposed to find, but in square kilometers. Now to do this, first I'm going to write the scale that is given to us in the form of a fraction. So I'm going to write it as 1 over 25,000. So here, the actual measurement is written at the bottom. So 1 over 25,000 is written. Now, this is something to do with the area. So now this is like the previous question that we did, where when a scale factor, the linear scale factor is given, to calculate the area scale factor, we will have to square it. So I'm going to square this. So when I square this, I get 1 squared, which is a 1 over, I'll write this as 25,000 squared. Now, this should be related with the area that is given to us. The area of the lake is 33.6 square centimeters. This is the area on the map. So that means that should be written at the top, which is 33.6, because this 1 is the measurement on the map. And this is the actual measurement. The actual measurement is written at the bottom. And that is what we are supposed to find. I'm going to label this as X, because that is what we are supposed to find. I'm gonna cross multiply it to find what x is. So the value of x will be equal to 33.6 times 25,000 squared. This 33.6 that we have here is given in square centimeters. I need to convert the total answer that I get here. So this answer that I get here will be in square centimeters, but I need to convert this into square kilometers. So to convert that, when we have kilometers, to convert it into, okay, there is a pattern. So we have kilometers, meters, centimeters, and then we have millimeters. To convert kilometers to meters, I need to times it by 1,000. Then I need to times it by 100. And then I need to times it by 10. So this is how I convert a larger unit to a smaller unit, by multiplying. And there is a pattern like I mentioned. But when it comes to area, all these units that I have here will get squared. So I'm going to write the same thing, but I'm going to write it with a square. So when I write it, the same thing will be written, but with a square. So I'm going to write as kilometer squared, meter squared, centimeter squared, millimeter squared. Just like the units got squared, this amount that we use to convert also will get squared. If I'm to do something with area, means the units will get cubed here. The amount that is used to convert also has to be cubed. So here it has been squared. Now I need to convert square centimeters to square kilometers. So I need to go this way. That means I need to convert it into square meters first and then square kilometers, which means when I go the other way around, I have to divide it. So I need to divide by 100 squared and then by 1,000 squared. That means this amount that I have here, I need to divide it by 100 squared and then 1,000 squared to find the value of x. That will give me the area of the lake, which is the actual area of the lake in square kilometers. So I'm going to put this in the calculator. So then we have 33.6 times 25,000 square divided by 100 square times 1,000 square. So when I do that, I get 2.1 as the volume, as the area. So this 2.1, and this is in square kilometers. This is going to be my answer. Let's see what we have next. The next question is also an important question. That is, when a table like this is given to us, we need to calculate the height of each of these remaining bars, where the height of one class interval is given to us as 7 centimeters. So this is something to do with histograms. So in this case, first, when we draw a histogram, we calculate the frequency density. The frequency density is equal to the frequency divided by the class width, which means I first need to find the class width to calculate the frequency density. So the class width is 15 to 25 is 10. Then I have 25 to 30. So 25 to 30 is 5, 30 to 50 is 20, then 50 to 80 is 30. Next, the next thing that we need to know is the frequency has to be divided by the class width to calculate the frequency density. I'm going to calculate the frequency density. So this number of people, which is the frequency, should be divided by the class width, which means this 35 is divided by 10. So we get 3.5. 32 divided by 5, we get 6.4. 44 divided by 20, we get 2.2. 12 divided by 30, we get 0.4. Now I know the frequency density. Now this has to be related with the height of each of the bars. Now it clearly states that in the first part of the question that this 15 to 20 centimeter column, the class interval, has a height of 7 centimeters, which means this 3.5 is 7 centimeters. So for me to make this 3.5 into a 7, I need to times it by a 2. I must do the same thing for this 6.4 and to this 2.2 as well, and to this 0.4 as well. These will be the heights of each of these bars. 6.4 times 2 is equal to 6.4 times 2 is equal to 12.8. That is the height of this bar. 2.2 times 2 is 4. That is going to be the height here. 0.2 times 0.4 times 2 is going to be 0.8. That's going to be the height of the third bar. These are going to be the heights of each of these bars. With that, we will be done with the questions that we have here. So these are actually some of the predictions. So all the very best for the test, and let's hope we expect what we expect here. And thank you for watching.